Artificial intelligence. It's been theorized since the early days of computing, for decades and decades now. Can we teach machines to think like humans? The answer, of course, is yes, but it's taken countless breakthroughs to get where we are today. One facet of artificial intelligence, called machine learning, has been gaining popularity recently in the cybersecurity industry. See, in the good old days, we used to feed our systems with mugshots of viruses, called signatures. We'd say, hey, this is an exact copy of this virus. This is exactly what it looks like. So if you see it, stop it, okay? That worked well for a while, but cyber criminals got smarter. They started giving their viruses a fake mustache, or a last-minute haircut. Our mugshots still caught a bunch of bad stuff, but the particularly crafty and advanced stuff could make its way through. Enter machine learning. With machine learning, we could feed characteristics-based information into our systems. Instead of looking for exact mugshots, we could say, hey, here's what the eyes look like, here's what the mouth looks like, here's what the nose looks like. So no matter the mustache or the haircut, as long as we spotted the characteristics we were looking for, we could be reasonably certain we had our criminal. This is great technology, but there's a problem. It doesn't scale well. For starters, we have to know what we're looking for, and we have to manually train our systems to look for it. Second, it's really hard to feed millions and millions of files into a system to be analyzed this way. Instead of looking at each file's face, you now have to look closely at the eyes and the nose and the mouth and whatever else we tell it to look at before we can move on to analyzing the next file. The more data you throw at machine learning, the more it slows down. Enter deep learning, a subset of machine learning. With deep learning, we scale back the human element exponentially. In the case of malware, for example, we pump a bunch of known malware data into the system and run it through a neural network. In your own brain, you have about 100 billion neurons, all connected together and all sharing information with each other. They take in data and process different pieces of that data, no matter how seemingly insignificant, in order to make judgments about what you're seeing. Same idea with neural networks associated with deep learning. We feed data into a deep learning system, and it's broken down neuron by neuron, starting simply and gradually getting more complex. Frontline neurons may say, hey, that's a line. Hey, that's a curve. The next neurons may say, okay, that's a rectangle, that's a circle. Then more complex objects, that's a nose, that's an eye. The more computing power we throw at this system, the deeper it thinks. In fact, deep learning will pick up on things, tiny little details, that humans can't possibly imagine. So while a traditional machine learning system is dependent upon inputs from humans, here are the eyes, here's the nose, here's the mouth, deep learning consumes a bunch of raw data and then develops its own set of characteristics to look for. Unlike traditional machine learning, the more data we pump into these deep learning systems, the better they get. We're finally to the point where advanced computing peripherals are cheap enough that we can build these neural networks with off-the-shelf hardware, all while analyzing malware far faster than machine learning systems, with a far smaller footprint and with better detection rates. So while many next-generation security companies will tout their machine learning technology, at Sophos, we're already light years ahead with deep learning. It's faster, it's more efficient, it's highly accurate, and the best part, it gets even better as it scales. For more information about deep learning, visit sophos.com/deeplearning today.